Okay guys, I welcome you all to Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now we are going to solve this problem which says that when the 6 kg box reaches point A, it has a speed of 2 meters per second. Determine the angle theta at which it leaves the smooth circular ramp and the distance as to where it falls into the cart. Neglect friction. So we have to find this angle theta at which the box will leave this circular ramp. So let's say that this point B is that arbitrary position where the box leaves the surface of this ramp. Let's say, so the box is somewhere here at point B. So if the box is somewhere here, so its weight is going to act vertically downward. So I will only show the weight. So the weight of the box is going to act vertically downward. This is the weight. And if we consider the normal and tangential coordinates, so the normal axis will always act towards the center of this circular ramp. So this will be our normal axis, and the tangential axis is going to act in the tangential direction, right? So in the direction of the tangent to the path. So this is our tangential direction, like this. So this is our positive t. Now if it here from here to here the incline is making 20 degree, it is given. So let's say if I draw a horizontal line here, let's say at point A, if I draw a horizontal line here, so this line which is parallel to this incline will make an angle of 20 degrees. This angle is 20 degrees, this is given here. So, and now if I draw a vertical line at this particular point, let's say if we draw a vertical point here, so this angle is 20 degrees, and as we can see that this vertical line is perpendicular with this horizontal line, and this line, let's say that this OA line is perpendicular with this line, a line which is parallel to the incline. So if the angle between this blue line and this horizontal line is 20 degrees, then the angle between this OA line and this vertical line is also 20 degrees. So this is 20 degrees. Now at point B, the surface is going to apply the normal force, and that normal force is going to act in this direction, that is in the negative n direction. So now if I extend the normal axis, if this is the normal axis, so if this angle is theta and this is 20 degrees, so this whole angle is theta plus 20 degrees. So this is theta plus 20 degrees. So if this is theta plus 20 degrees, then this angle is also theta plus 20 degrees, since both of these angles are alternate angles, right? This line is parallel to this line. So this angle, this whole angle is equal to this whole angle. So if this is theta plus 20 degrees, then this angle is theta plus 20 degrees. So this means that the weight is making theta plus 20 degrees with this normal, right? So this is theta plus 20 degrees. Let me write that this is theta plus 20 degrees. Now if we resolve this weight, so this weight will have one component in this direction, this will be towards the positive normal direction, and this will be weight cos of theta plus 20 degrees. Now if we apply the summation of forces along the normal direction, so that will be equal to m an, and as we know that an is always equal to the velocity square divided by rho. And if we are applying at some arbitrary position point B, so this will be VB square. So now as we can see that this normal force is acting in the negative n direction, so I will write minus n, and then this component is acting in the positive n, so I will write plus, and W cos of theta plus 20 degrees, and this will be equal to the mass. So mass is 6 kgs, 6 VB square divided by rho. So rho is the radius of curvature. So the radius of curvature is 1.2. The radius is 1.2 meters. So I have to divide it by 1.2. Now in the problem statement it said that determine the angle at which it leaves the smooth circular rim. So wherever the box will leave the surface at that particular point, and the normal force of the surface will be equal to 0. So let me write that n will be equal to 0. So if n is equal to 0, we are left with this equation. So from this equation we can write that Vb square will be equal to 1.2 W cos of theta plus 20 degrees and divided by 6. And now we know that the weight is mg and the mass is 6, so this will be 6 into, so let me write that this is 1.2 W and W is 6 into 9.81. So 6 will cancel out, so this will be Vb square will be 1.2 into 9.81 cos of theta plus 20 degrees. So this is Vb square, right? So let's say this is our equation 1, and now if we apply the law of conservation of energy, so that says that the kinetic energy at point A plus the potential energy at point A will be equal to the kinetic energy at point B plus the potential energy at point B. So the kinetic energy at point A is 1 divided by 2, mass is 6 times Va square, the velocity at A. So the velocity at A is given, which is 2 meter per second. So this is 2 square plus the kinetic, the potential energy at point A. So for that, let's say that we define our datum line at point B. Let's say that this is my datum line. This is our datum or reference line for the gravitational potential energy. So if this is our datum line, then from here to here, this length is this 1.2 cos of 20 degrees. Let's say that this is point C. So we can write that OC length is 1.2 cos of 20 degrees if we consider this OAC triangle. So this is 1.2 cos of 20 degrees. And similarly, if we consider this OBD triangle, let's say that this intersection point is D. If we consider this OBD, then this OD length will be 1.2 cos of this angle, which is theta plus 20. This is theta plus 20 degrees. Now the potential energy at point A will, the gravitational potential energy at point A will be weight times h, and h is the distance from the datum line. So this is that h. So we can write that weight is 6 times 9.81, and h will be this OC length minus OD. So we can write that this is OC minus OD. So this is the gravitational potential energy at point A. And now we can write that this is 6 into 9.81. This is 9.81. And OC is this 1.2 cos of 20 degrees minus this 1.2 cos of theta plus 20 degrees. And now we can take 1.2 common as well. So that will be 1.2 cos of 20 minus cos of this. So this is the gravitational potential energy at point A. So I can write this as 1.2 into 6 into 9.81 cos of 20 degrees minus cos of theta plus 20 degrees. So this is VA. So now I will write that VA here. So this is 1.2 into 6 into 9.81 cos of 20 minus cos of theta plus 20 degrees. And then the kinetic energy at point B is 1 divided by 2, mass is 6 times Vb square, which is not known. And if the box is at point B and we have defined our datum here, then the gravitational potential energy at datum will be 0. So this is equal to 0. So this is, if I divide this whole equation by 6, So this 6 will cancel out, this will cancel out, and this 6 will cancel out. So we will be left with this equation. And now if I multiply this whole equation with 2, so we will multiply this with 2, we will multiply this whole term with 2, and then we will multiply this with 2. So this will cancel out and this will cancel out. So now we are left with 2 square, which is 4, plus this is let me write it as, let me multiply this with this cos of 20 and this. So we can write this as 2 times 1.2 into 9.81. So 9.81 into cos of 20 degrees, and similarly if I multiply this with this, so that is minus 2 into 1.2 into 9.81 cos of theta plus 20 degrees, and this will be equal to VB square. And now if we look into this equation, then 1.2 times 9.81 cos of theta plus 20 degrees, this is equal to VB square. So from this we can say that this 2 into 1.2 into 9.81 cos of theta plus 20 degree, this whole product is equal to VB square. So we can write that this is VB square. So this is 4 plus 2 into 1.2 9.81 cos of 20 degrees minus 2 VB square. This is equal to VB square, and this is equal to VB square. And if I bring this to the other side of equation, so it will become 3 VB square. So this is 2 VB square. So this will, on the other side of equation, this will become plus 2 VB, and if we add this, so this will become 3 VB square, right? This is 3 VB square. And if I divide both sides of equation by 3, so we will have VB square equal to this, and if we take the square root, then we will be able to find VB. So this is VB. Now VB is square root 4 plus 2 into 1.2. Let me take the square root. So square root 4 plus 2 into 1.2 into 9.81 cos of 20 divided by 3. So this gives us, this is multiplied by, right, so this is 2.95. so VB, the velocity of the block where it will lose contact with the surface, so at that particular point VB is 2.951 meter per second. So this is that velocity which was required, and then we were required to find that theta. So now if I put VB in this equation 1, so we will be able to find that theta. So now from equation 1 we can say that VB square, so VB square is 2.951 square, and this is equal to 1.2 9.81 cos of theta plus 20 degrees, and from this equation we can say that cos of theta plus 20 degrees is equal to 2.951 square divided by 1.2 into 9.81, and if we take cos inverse of this, that will give us theta plus 20 degrees. So now the cos inverse of this is equal to 42.289. So theta plus 20 degrees is 42.289 degrees, and now we can find theta. So theta is 42.289 minus 20 degrees, so this will be equal to 22.289. so this is 22.289 degrees. So now this is that theta for which the box will lose the contact with the circular ramp. Now after that, in the problem statement we were asked to determine the distance s that it will travel. So we have to find this distance s. So now for that, after point B, when it loses contact with the ramp, it follows the projectile motion. So if for projectile motion, let's say that our coordinate system is located at point B. Let's say that this is our coordinate system. So this will be the initial position of the projectile, So this is the x direction and this is the y direction. This is the positive y and this is positive x, and the velocity is going to act perpendicular to tangent to the circular ramp or circular arc. So let's say that this is that velocity which is going to act in this direction. So this is VB. Now as we can see that this VB is perpendicular with this radial line. If we draw a line from that O to this point B, so this VB is perpendicular to this line and this x-axis is perpendicular with this vertical line. So the angle between these two lines is theta plus 20 degrees, as we have already discussed. This angle is theta plus 20 degrees. Both of these angles are alternate angles. So if this is theta plus 20 degrees, so now we know theta plus 20 degrees, which is 42.289. We have just determined that theta plus 20 is 42.289. So we can say that this angle is 42.289. So if the angle between these two lines is 42.289, then this angle is also 42.289 degrees. Now for that we can resolve this VB into its components. We will have one component. So the velocity component in the x direction is this. This will be VBx, the component of the velocity in the x, and this will be VB cos of that 42.28, and VB is known. This is 2.951. So we can say that this is 2.951 cos of 42.289. And similarly its vertical component will be acting in this direction. This will be VBy. This is VBy, and this one will be the sine component. Now we will apply the horizontal equation for projectile motion. So we know that x is equal to x naught plus VBx into t and plus ax into t. So in projectile motion, the horizontal component of the velocity remains constant, so there is no acceleration in the x. So this will become 0 and it will fall somewhere here. Let's say that this is its fall point. So the final coordinates of the position of the box is this. So from the origin, the box need to travel s distance in the x, and in the y it need to travel this much distance. And if this is 42.289 and this is 1.2, so then this is 1.2 cos of this. So the y coordinate of the final position is 1.2 cos of 42.289. So let me find this 1.2 cos of 42.289. This gives us 0.887, or we can say 0.888. This is 0.888 meters, right? So these are the final coordinates of the position of the box. So in the final coordinates is x, this is x, and the final coordinate is y, and the initial coordinates are x naught and y naught. So x naught is 0 and x is s, and VBx is this, which is 2.951 cos of 2.951 cos of 42.289. This gives me 7.361. This VBx is 7.361. So this is 7.361 into t. So now in this equation we have two unknowns. The s is unknown and t is also unknown. So let's say this is equation 1. And now if we apply the equation for the vertical motion, for considering the projectile motion, and this is our positive y direction, remember this is our positive x direction. So now again we will apply the same equation but in the vertical direction. So that is y equals to y naught plus VBy into t plus ay into t square. This is t square, remember, and this is 1 divided by 2 ax t square, remember. So this is 1 divided by 2 1 divided by 2 ay into t square. Now again the final position is y is 0.888, this is 0.888, y naught is 0, the initial position, the initial y coordinate is 0, and vby is 2.951, sine of this will be 2, this is 2 point, remember we have done a very small mistake, this is remember that this is 2.951, so this is 2.18, this is 2.18, remember this is 2.18 into t, and similarly this is 2.951 sine of that angle, so this is vby, this is sine, this gives us 1.986, so 1.986, and as we can see that vby is acting in the negative y direction, this is positive y, so this will become negative, so we will write that this is plus, and this is the component is negative into t, and then 1 divided by 2, and in the downward direction the velocity is increasing in the negative sense, so the box is, the acceleration is negative, the acceleration will be positive in the positive y direction and negative in the downward direction, so we will write minus 9.81, so ay will be minus 9.81, and this is t square, so this is 0.888, and this is 1 point, this is 1.986, this is minus 1.986 into t, and this is minus 9.81 divided by 2, this gives us 4.905 minus 4.905 t square, and if I bring these two terms to the other side of the equation, so we will have the equation like this, 4.905 t square plus 1.986 t plus 0.888 equals to 0. So this is a quadratic equation. In terms of t, we have to find the roots of this quadratic equation using calculator. So we can use this 5, this is equation, and then the quadratic equation, and the coefficient of t square is 4.905, coefficient of t is 1.986, and 0.888, so this gives us, so this is giving us complex root, as we have done a small mistake, since this is this coordinate is in the negative y, so this is, we need to write minus sign with it. So this is the mistake we have to correct ourselves. So this is minus 0.888, this is minus, so now this is minus. So now if we put this root, this is minus 0.888, remember this is minus coordinate, so this is, when we equate it, so t equals to 0.269 second, and similarly the other root will be negative, so time cannot be negative, we have to take this positive root, so the time the box will take to cover this horizontal distance s is 0.269 second, when vb is 2.951, and similarly we were required to find this s. Now we have this equation 1, so according to this equation 1, s is equal to 2.18 into t, which is now known, which is 0.269. So we will multiply that time with 2.18, so 2.18 multiplied by 0.269, this gives us s, which is 0.586 meters. So this is that horizontal distance the box will cover when it will just lose the contact with the circular rim. So this is the solution of this particular problem. I hope this will help you in your learning. Let me know in the comments if it helps in your learning. Also hit the subscribe button if you haven't done it